Hello class, this is a video tutorial on bivariate data. In this video we're going to be looking at the least square line of best fit, part 2. In this video we're going to be looking to manually calculate the least square line of best fit that has the equation y equals mx plus c. In order to calculate this, there are 5 key calculations we need to do. Well, actually no, 5 key points that we need. We need R, Pearson's correlation coefficient, X bar, the mean of the independent variable, as well as the standard deviation of the independent variable. In case you've forgotten which is the independent variable, it's the one that belongs on the horizontal axis. The mean of the dependent variable is also required, as well as the standard deviation of the dependent variable on the vertical axis. The key values required from the least square of line of best fit is as follows. We need to find the gradient m. And how to find that is we take r value, we multiply it by the the y standard deviation by the x standard deviation. A good way to remember this is because y is the rise and x is the run. Okay, and remember s of x is the horizontal standard deviation. And lastly, we need to calculate the value of c, and how we do that is we take the mean of the y values, we subtract it by m times the mean of the x values. And notice how we require the mean in this equation, which was calculated previously here. Hopefully this will make a lot more sense when we do an example here. Let's calculate the equation of the least square line of best fit given the following pieces of data. So we have all these pieces of data. Let's calculate our equation y equals mx plus c. For this, I'm just going to copy this down so we don't need to keep sliding up and down. We'll leave it right here for us to see. So let's calculate the mean first. Let's grab our calculators. Here we go. So to calculate the mean, we need, so let's put this, m is equal to r times s of y over s of x. The r value in this question is listed here. So negative 0.76, so let's input that in. Times, let's put this in brackets. We need the standard deviation of y, which is here, 5.71. Let's write that in. Over the standard deviation of x, which is 6.43, it's listed there. We just input this into our calculator. Let's write this in. Negative 0.76 times 5.71 over 6.43. Calculating, we get negative 0.67489 ... Okay, and we're going to round this later to however many decimal places we need, but for now we're going to just use the entire value. Let's now calculate the value of c. Let's write this down again so we remember. So c is equal to y dash minus m times x dash. Y dash, we can also write this as y bar, or the mean of the y values, which is 59.18. Let me zoom out a little bit here. So the y value is listed here in the question, 59.18 minus m. Our m value is actually here. I'm going to use all 4 decimal places for now. So negative, so we're going to do minus negative 0.6748 times the x mean, which is listed here. So that's going to be 100.79. Inputting this into a calculator, we will get 59.18 minus negative 0.6748 times 100.79. Pressing equals, we get 127.19309. 127.19309. Dot. Now that we have all those values, we can finalize our equation because we now need both those values to finalize this equation here. So we have the m value here. Let's substitute that in. We get y is equal to m. Now I'm going to round this off to however many decimal places we want. For this one, let's round off to 2 decimal places. So our m is now going to be negative 0.67x plus the value of c here. I'm going to round this off, approximately 127.19. And that there is the equation of least square line of best fit. You can pause the video and give this a go yourself, because I'm going to be answering this in about 3, 2, 1. All right, here we go. So for this, we need the 2 equations. Let's write it down again. I need the value of m, which is given as r times sy over standard deviation x. And also I need the value of c, which is equal to the mean of y minus m times the mean of x. So let's write this all in. The r value here is given there, so 0.946 times s of y, 40.134, divided by the s of x, which is 3.598, which is equal to, let's use our calculator now, 0.946 times 40.134 over 3.598. This is equal to 10.55218. Now let's use that value to calculate the value of c. Let's calculate the value of c. We need the mean of y, which is given here, 78.135. Minus the mean, which is given here. Let's put that in brackets. 10.55218 times the mean of x, which is given here, 5.631. Inputting this all into our calculator, we will get 78.135 minus 10.5512, 218 times 5.631. And this gives me a grand total of 18.71567. Let's round both of these off to, let's say, 3 decimal places for this example. You can round off to whatever the question asks you or to whatever value that you want. But for this one, I'm rounding them off to 3 decimal places in this one question. Putting all this together, so the final equation should look like y equals mx plus c. wrong color. M is shown here, and C belongs there. So our final equation equals y equals 10.552x plus 18.716. So I hope that gave you an insight into calculating the least square line of best fit manually, given the key data points. Hope to see you in the next video. Best of luck.